We're on page 17 of your algebra book. We're going to do problems 6 through 11. They are word problems. We're going to write some equations and solve the word problems. We're going to start with number 6. Working 40 hours last week, John earned $335. If $85 of this amount was earned as tips, what is John's hourly pay rate? So right here, it already has his hourly pay rate labeled as R, so that's going to be a variable. He worked 40 hours last week, so 40 times R. Plus $85 of that was tips, so that's plus 85. And then he earned in total 335 equals 335. So now we just have to solve for R. Put up our barrier wall. We got to get that R all by itself, but first we had to move that plus 85. So we're going to subtract 85 from both sides, leaving us with 40R equals 335 minus 85, which is 250. We're going to get the R alone, so we're going to divide both sides by 40. And his rate is, and since this is his pay rate, we're going to we're going to put a dollar sign. So 250 divided by 40, and that is $6.25. That's his hourly pay rate. Okay, so number 7. Each month, Lonnie deposits money in her savings account. After making 8 equal deposits, she placed her bonus, so that's a plus, of $250 in this account. She now has total $930 in savings. How much does she normally deposit? So we're looking for that D. So she made 8 equal deposits plus her bonus of $250. In total, her total amount equals $930. Okay, so we're going to solve for D. Going to do that by subtracting $250 from both sides. So we have 8D equals $930 minus $250, which is $680. We're going to divide both sides by 8. And we're going to end up with D equals $680 divided by 8. So she started with $85. Okay, this next one. These type of problems give people trouble, but you just have to read and kind of think it through. Consecutive even integers. So we're looking at even whole numbers. Are even whole numbers that follow one another. For example, 10, 12, and 14. So we know. We have 10, we have 12, and we have 14. Those are examples. If the sum, so we know they're going to be added, of all three of these is 84, what is the smallest of the three integers? Okay, so x is our variable, and that's an integer. The smallest, actually. Smallest. And we know all the integers are going to add up to equal 84. But how do I know what to start? So what to put as my variable. So our first one is x. Our x is 10. So to get from 10 to 12, we just add 2 to that 10. So we're going to do x plus 2. Once again, looking at our x is 10. To get from 10 to 14, we got to add 4. So x plus 4. So all of these integers up here, we're just going to add them up because it says the sum of them. So we have 1x plus 1x plus 2 plus 1x plus 4. Okay? So now we have all of these yellow x's to combine our like terms, and we have all of these purple numbers to combine as like terms. So let's go ahead and combine our like terms first. So we have 1x plus 1x plus 1x is 3x. And we have 2x plus 4x is 6x. All of that equals 84. So you're going to subtract 6 from both sides. We have 3x equals 84 minus 6 is 78. We're going to divide both sides by 3 to get x equals 26. And 26 is our smallest integer, smallest number there. Okay. Number 9. If you subtract 6 from 4 times Sean's age, you get a number equal. So there's going to be an equal. There's going to be a subtraction and a multiplication to twice his age. How old is Sean? So X is Sean's age. And it says 4 times. So subtract 6 from 4 times Sean's age. So 4x minus 6 equals twice his age, 2x. So we have 4x minus 6 equals 2x. Now remember, I get these purple x's together. It's going to do that by subtracting 4x on the left. It's going to leave me with negative 6. Negative 6 equals negative 2x. Going to divide both sides by negative 2. X equals positive 3. Sean is 3 years old. Okay, number 10. Eric removed 500 pounds of gravel from a loaded truck. So we're going to subtract 500 somewhere. Jake then takes 3/4 of the remaining gravel. If the amount Jake takes is equal, so there's going to be an equal, to 1/2 the original full load, how many pounds of gravel were originally loaded into the truck? So our variable is X. This is original pounds of gravel. Okay? So our equation here is 3/4 of this total, the original G minus 500 equals 1/2. Oh, I want to put X. I'm sorry, not G. X minus 500, 1/2 X. Okay, so that's our equation. So I'm going to write it down a little better over here. 3/4 parentheses X minus 500 equals 1/2 X. I got to distribute this 3/4 to everything in the parentheses, so I have 3/4 X minus, so 500 times, don't forget to use your calculators, 3/4 is 375 equals 1/2 X. Okay? I'm going to subtract 3/4 X to our dividing wall from both sides. Left hand side, I'll end up with negative 375 equals 1/2. Plug that in your calculator. 1/2 minus, and then plug in 3/4, and you should get negative 1/4 X. Now we're going to divide both sides by negative 1/4 X, or negative 1/4, sorry. So we're going to end up with X equals, so we got negative 375 divided by negative 1/4, and X equals 1,500. So 1,500 pounds, that was the original amount of gravel. Last one. Alan reduced, so reduced is a subtraction, his work hours by 6 hours per week. Now he works in 8 weeks 6 fewer hours than the total number of hours he used to work back in 7 weeks. Before cutting back, how many hours, so we're looking for hours, did Alan work each week? So X equals his hours original before he cut back. Okay, so 8 weeks, 6 fewer hours than the total number of hours. So that's going to be 8 times X minus 6, and then 7 X minus 6. Okay. So we have to distribute this 8 to everything inside. We have 8x negative 6 times 8 is going to give us minus 48 equals 7x minus 6. So I'm going to move my purple x to the right. So 7x, to the left, 7x. Going to move my problem up here. So I will have 8x minus 7x is just x, minus 48 equals negative 6. So I'm going to add 48 to both sides. So x equals negative 6 plus 48, and that gives me 42. His original work hours were 42.